Hello, everyone. We're going to give it 1 or 2 minutes before we get started here to allow attendees to join. So we'll be getting started in a minute. All right, well, it looks like we have some attendees joining now, so we'll go ahead and get started, do a little housekeeping before we get to the main presentation. My name is Joseph Dieno. I'm a principal here at Interface Engineering, and I'd like to welcome everybody to Interface Engineering's 2025 Educational Webinar Series event, The Balance Between Lighting Design and Sustainability, presented by Associate Principal Kristina Santi. Thank you for logging in today. Just as everyone is aware, we're using a GoToWebinar meeting platform. And we'll give you a little brief overview of Interface Engineering. We are an MEP consulting firm providing MEP engineering, fire life safety, building technologies, and AV design, lighting design, energy analysis and commissioning. And we have offices all over the United States. Today's presentation will be recorded and made available through our website. All audience microphones will be muted during the presentation. And please feel free to enter your questions into the questions field. You can see the housekeeping slide we have up now. We want to make sure that everyone is able to enter questions. So if you're using the web version, there's a control panel on the top right-hand side. You can click the question mark to expand the panel and enter your questions there. If you're using the desktop version, the control panel, there's a small vertical menu bar. You can click the red arrow to expand the pane. And then if you go down to the question header, it's best to undock it from the control panel and enter your questions in that way so that you can see everything. Interface Engineering is an approved AIA-CES provider. For today's participation, you'll earn 1 learning unit. All attendees will either receive a course completion certificate, or if we have your AIA number already, attendance will be reported for you to the AIA within the next 2 weeks. We'll try to leave 10 to 15 minutes at the end of the presentation to answer your questions. If we're not able to get through all of the posted questions, we will distribute a Q&A summary to everyone. So with that, I'd like to turn it over to Kristina for the presentation.
Thanks, Joseph. Hi, everybody, and welcome to The Balance Between Lighting Design and Sustainability. Thank you for joining us today. So a little bit on the course description. We're going to discuss how lighting design and sustainability can work together and how lighting choices have impact on the environment, but we also want to create good lighting design for the benefits of the user and for the comforts of the users for this space. So we're going to talk about all those together, and so we can come up and provide optimal lighting solutions for our buildings. Some of the learning objectives. We're going to learn a little bit about code requirements. So I know we have a few people from the East Coast as well, so we're going to talk about a few different codes that affect us. We're going to learn about sustainable lighting options, how we can use those in our designs. We're going to talk about WELL and LEED credits and how they help drive down the carbon footprint, and talk a little bit about Living Building Challenge and Declared labels and how they work as well. We're going to learn about the life cycle analysis and environmental product declarations and how all those come together and have an impact on sustainability. And then we're going to bring all those together and for lighting design and how we can balance them out to provide the optimal lighting solutions. So a little bit of an introduction, and I know sustainability is a hot topic at the moment, especially with all the changes to our climate we're seeing on the news, the floods, the wildfires. We all want to be more sustainable in our designs and decrease our impact on the environment. The IES and the IALD have a really great definition for sustainable lighting. They define it as meeting the qualitative needs of the visual environment with the least impact on the natural environment. So I think that really sums up how we're trying to balance out the needs of the users and the visual environment, and also have the least impact on our environment overall. And the IES does have a lighting sustainable publication that you can read. That's the IES LP10. So if I could take a look at that if you have some time. Lighting has been estimated to account for about 6% of energy in homes and 17% of energy in our commercial buildings. This is based off a 2018 US Energy Information Administration study. And before that, we had fluorescents and we used a lot more energy. And so we had the LED revolution where we came and LEDs brought down that energy usage by quite a lot. And we were losing a lot of lighting energy to heat in our old fluorescent and HID sources. So we've come a long way in the last 20 years or so, but there's still more room to go. I'm excited to see what the future brings. So before I start, I wanted to kind of run through some of the codes and certifications that we have available out there. And we're going to talk a little bit about these within the presentation as well. So I wanted to go through so that everyone's aware what these are and what they do. On the left-hand side, we have our codes. So for California, we have the Title 24 Energy Code, and we have the JAA. So that's a residential code for residential lighting fixtures for energy efficiency. So you may see these two stickers on cut sheets for California projects. And then for our other states, we have the IECC code, Energy Code, and you might also be aware of the ASHRAE codes as well. Then in the center, we have our certifications. So we have our LEED certifications for lighting. That's the lighting pollution credit, and also the lighting quality credit as well. And then well building standards, there's a whole bunch of lighting points that you can get there as well. And then on the right-hand side, we have individual product certifications. So we'll have Declare labels for individual products, some red list free products or red list approved. And we also have our DLC listed products. So DLC put out a list that you can look at online of approved energy efficient fixtures. And we see these used a lot as specified for our educational projects where clients will make sure that they're listed as DLC. Some of the challenges of being sustainable in relation to energy codes. Energy codes are great. We're trying to keep our energy down in our buildings. And sometimes that's a little bit challenging, especially with lighting power density limits. They're getting quite low, and we're trying to meet those, but also meet the amount of light that we need into the room. So for Title 24 California, there's some new requirements that start January 1st, 2026. Our previous code cycle did see some very drastic changes in the lighting power density. We saw some really big reductions with office buildings, school buildings, and assembly buildings, going down to 0.6 watts per square foot for most of those. But the good news is that for 2026, there's no further lighting power density changes. So we can keep trying to meet those pretty stringent lighting power density levels already. We do have some issues trying to meet these levels. Every building is very different. So if you have a large building with very large open spaces, you can space your lighting fixtures out quite far. So 12 to 15 for linears in an open office, 12 to 15 feet you can get. But if you have a very dense floor plate with lots of small offices, you're going to need a light in each one of those, and then your lighting power density overall goes up quite a bit. So sometimes for small TIs, we do have issues meeting the lighting power densities, but there's some little tricks and tips that we'll go through on how to beat those. Make sure as a lighting designer or anyone working in lighting, you coordinate early with your engineer of record, do checks to make sure you're on track with your lighting design and your code lighting power densities. There was some healthcare changes recently for Title 24. They have some limitations, so you do not need shut-off controls or dimming. There's exceptions, but you do need to have a manual area control, so switch, and you do need to meet the 0.9 lighting power density for healthcare, which is quite high for now. But just because we don't need to provide these per this code doesn't mean that we shouldn't consider them. Tunable white circadian lighting has great benefits for healthcare. There's been studies to show that patients that are in their patient rooms for long hours can heal quicker with circadian lighting. So having a warmer, dimmer light at night and having a brighter light during the day to mimic the daylight hours. Also, staff that work night shifts, there's benefits for them as well. And definitely dimming, having dimming in these spaces to bring the lighting energy down. It's a great way to save energy. So something to think about. Now for the rest of our states, maybe some of you that are calling in today, the IECC 2024 is now coming in that has stricter lighting power densities, some mandatory lighting controls, and it has the demand response for lighting and HVAC as well. So this is a state-by-state basis. Some states are looking to adopt this new code. You can see on the right a little map here is showing, we're very different in our energy codes and the current code that each state is using. But something to look out for if this 2024 code is adopted by your state. And then also the ASHRAE 90.1 2022 has come out as well. So now in March 2024, the DOE determined that the 2022 version saves energy compared to the 2019 version, and it now requires all states to adopt it or an equivalent by 2026 in order to receive enforcement funding or to justify why they cannot comply. So that's something coming as well. And you can see the map for 90.1 is a little bit more up to date in terms of the states that adopt it. So something to think about, and to that 2026 date's coming up. So some solutions. So what can we do when we have these higher lighting power density levels that we have to meet? We want to be sustainable, we want to save energy, but we also want to provide good lighting and comfortable lighting and enough lighting for each space. So really understanding your codes, knowing your codes as a lighting designer is really important. Knowing where you maybe have some additional lighting power allowances, making sure you're using the right type of building. If you have an alteration, that's very different to new construction. So making sure you're using all the code requirements for special areas that you have available to you, so that you're not having to remove lighting and remove layers of light, just to make sure that we can get what we need to meet the IAS standards, ISNA standards for recommended lighting levels, and also meet code. So there's that balance there. So there's some health impacts. So, while we have this energy code and it's pushing us to have less and less wattage out of our fixtures, sometimes that has a negative impact. Pushing just so much light out of a fixture without shielding it is not great for comfort. There's glare issues. You can see this kind of fixture on the top here where we just have no lens and bare LEDs. Maybe that's great for a storage room, but we definitely wouldn't want to put anything like that in an office space or where there's people spending long periods of time working. Also, you can see in the image on the bottom of that, setting an LED back into a deep recessed fixture really shields that glare source, so you don't see as much glare coming out of it as you do if you have a really shallow fixture. So making sure that I know that there's a little bit more housing involved, and we're always trying to make things smaller. Sometimes making things smaller makes them less comfortable. LEDs, they're great, but they punch out light in one direction. They're very different to how fluorescents used to work. So we want to make sure that we're really shielding those fixtures. We have a lens, we have a reflector. All these things are really great you can bounce light off them. But that also does bring down the efficiency of the fixtures. So they're not going to be pumping out as much light per watts per square foot. We've seen a big shift. I know with LEDs, they developed so far that then there became an issue of, okay, some of these are burning out. What do? I have to take out the whole fixture. A lot of owners and building managers are kind of complaining, I don't want to take out the whole fixture and throw it away. That's such a waste. I want to replace parts as much as I can, have my maintenance staff do maintenance on them as needed, and I don't want to pay for an electrician to come out and have to install new lights. So really trying to make sure that we choose lights with replaceable drivers and replaceable LED boards that we can access from below. They're just a really good choice. We don't want to throw away the whole fixture, and we want to make sure they're maintainable for our clients as well. So we're seeing more of these creep into the market. They're not always apparent on the cut sheet if it has replaceable parts or not. There's some that do. But really getting to know your fixtures, you're asking your manufacturer, how do these get replaced? Getting some real hands-on experience at looking at the fixtures and how they work is really important as well, how they're accessed. Another thing really important, maintainability. So making sure you're selecting the luminaires for where they need to be installed. Can they be accessed, especially in these wood type roll-on or Armstrong ceilings? Making sure we can get those fixtures out and replace parts as needed. Making sure that, is there a special tool needed to open the fixture, or is it pretty user-friendly? Making sure that you're picking a lens so it can be cleaned if you're in a dirty environment. Wipe down fixture lenses that are important in certain areas, just making sure that fixture is really suited for where it's going to go. Constructability is also a big one. Can this luminaire work with the ceiling and the shape? Is there enough space around them for all the other services? Just really coordinating everything so that it gets installed and maintained properly. And probably one of the most important thing is designing for lighting where it needs to go. So we don't have to have a lot of light in a circulation area, but where we have a task, where we have a desk, where we have an area that is used for people reading, we want to make sure that's where our light is going, and it's going on the task surface, and we don't need as much light in other areas. So balancing out that light is really important. If we have really high ceilings, do we want to have a recessed fixture that's just pumping out a lot of light to get all the way down the bottom, or does it make more sense to save some energy and maybe have a suspended fixture or a wall-mounted fixture where you don't need as much energy and lumen output to get to the surface that you're supposed to be lighting? So that one's a big one. Making sure that you're using the right beam angle, so with the right height of ceiling, and making sure that we don't use uplighting everywhere, and our uplighting is great, but we do kind of bring our lighting power density down a little bit when we're lighting up a lot because we're bouncing off the ceiling and down. But of course, uplighting is a great tool to use where it is needed. And that kind of brings us to reflectance values with indirect lighting. Reflectance values of surfaces really have a great impact on how much lighting we need in the space. Not only visually, and you can see a little photo down the bottom here, people are going to perceive, you could have the same fixture, people are going to perceive the area with the dark finishes as being a lot darker than the area with the light finishes, just visually. And then we have the issue of reflectance, of this light reflecting off walls and ceilings. So overall, you're going to have lower foot candles in the space. So to light this room with dark finishes, you're going to have to actually have quite a lot higher lumen output and energy fixture in this space. So making sure that you have these, you kind of take that into consideration, and the LEED lighting quality credit also lists surface reflectances as one of the points options that you can use. I know that's a little bit hard to determine because usually finishes are kind of at the end of the project, but it definitely affects the energy used if you have a lot of dark surfaces. So use sparingly and let your lighting designer know where they are, because that's very important. Now we can't forget exterior lighting. Exterior lighting is also very important. The International Dark Sky Association has 5 principles for responsible outdoor lighting. Make sure that the lighting is useful, number 1. So all light should have a clear purpose. Making sure that do we need a light here, being sparing with the light as needed and show up where you need to. And thinking about how it's going to impact the area, impact the wildlife and the environment, and using it in a considerate way. Targeted lighting. So light should only be going where it is needed. So if you're highlighting something, then you want it to be facing that direction. Don't have wasted light in other directions. Number 3, low light levels. So lighting should not be brighter than necessary. So making sure you're not overlighting spaces. Number 4, that your lighting is well controlled. Typically we need to have astronomical time clocks per code, but there's additional things that you can have, motion sensors, part nighttime dimming where you dim the lights down to a set level at a certain time in the middle of the night. So there's a lot of extra things we can do to save energy and also to not impact the environment. And color. Color is a big one, especially for wildlife. There's total friendly lighting with the amber, really warm color lights. That blue light also affects migration of birds, sea creatures. So making sure you're using those really warm lighting temperature colors in your exterior lighting designs is really beneficial. And here's some pictures, the good, the bad, and the ugly. So you can see on the left, this fixtures lighting the sky. There's a lot of these acorn fixtures that are kind of aimed up. They're not really lighting down when you need the light on the floor. So it was a few designs that were kind of aging, but you still see some around today. And then the one below that, just very glary fixture. You want to make sure that your light isn't spilling into any neighboring properties, residential windows. You want that light really directed down onto the driveway and the roadway. And then the ones on the right, and these are a little bit more landscape lighting, but you can't see any of the fixtures, they're all hidden. Landscape lighting is great to have those little snoots on the end and aiming them, at the landscaping and what you're trying to highlight and create depth and really low soft lighting levels. Just highlighting where people were wayfinding, highlighting features, the stone building, the trees as needed, just really soft and thoughtful lighting. Now we're going to go through a little bit about Declare labels and how we select sustainable airs. So a list of 10,000 harmful materials and chemicals were formed into the Living Building Challenge, LPC, red list. And so products that meet all these, that don't have any of these harmful materials or chemicals, can display a red list free declare label. And then for any products that have some exceptions to this, then they can display a LBC red list approved label. So any ingredient of the products that is over 100 parts per million needs to be included on this declare label. And you can kind of see on the right. So they have the life expectancy of the fixture, the embodied carbon of the fixture, end of life options on the fixture, or these can be used for other things besides lighting as well. So percentage that is recyclable, some that goes to landfill. So they have a list of all the ingredients that make up the fixture. And then they have a tick for, is it red list approved or is it red list free? Many lighting fixtures are red list approved. They do find it difficult with drivers and wiring and some aluminum, steel to get that red list free. So most of them we will see is red list approved. So you'll usually see this declare on the cut sheet, this declare symbol up here. And then you can dig a little deeper and you can find this whole label with all the information from your manufacturer. So LEED and WELL. So both the WELL standard version 1. So how do we use these declare labels and then bring them into required sustainability certifications? So we can use the declare labels are actually required in the WELL Building Standard version 1, feature 26 for enhanced material safety, and the WELL version 2 feature X13 enhanced material portion credits. So they both need a Living Building Challenge red list free or red list approved. And then LEED version 4 and version 4.1 for the building product disclosure and optimization credit. Option 1 also requires the declare labels. So red list free, of course, is very limited. So some of these are requiring a red list free. So just be careful that if you're using these on some of your projects, we can actually meet them, but we should try to, for sure. Now, one of the best ways to save energy is really to use daylight. And daylight is the best and most efficient way to light a space and the best way to start before we look at our lighting design. So there are many ways. I don't know if there's any architects on the call. You're the experts at this, but providing things such as light wells, light shelves, skylights, clerestory windows are all ways we can bring light into our building. Providing buildings have narrow floor plates, north-south facing windows, high ceilings and open sections. Of course, these will need to be within the project budget and are dependent on the location that you're at as well. And we also have to think about the heat that's coming into the space and balancing that out. So that's something that our energy team looks into quite a bit. So making sure that we have some lighting that's coming into the building for our occupants for their comfort, but also making sure that we're providing light surfaces and reflectivity in areas where occupants will spend the most of their time. And then usually there's some models that can be run to show the amount of daylighting in the space and on each floor and the footprint. So we can kind of use this and take this into consideration within our lighting designs. So making sure that controls account for where these windows are. So we have photocells located near windows, so they automatically dim the lighting within that daylight space at the window, so we're saving energy there. We balance the lighting out by maybe not having such a high concentration of lighting at these windows and facades, spacing them out to be towards more of the areas that are darker in the back of the footprint, and then maybe, you know, having just a little less lighting along those windows. We do have to think about how the building is being used. So if the building is used a lot at nighttime, we want to make sure that we're still providing sufficient light at nighttime. But maybe if this is a 9-to-5 office building, not so much. So daylight studies will show where this lighting is most concentrated based on the location and facades. It's shown in the little picture there. So how do controls affect sustainability and energy use? Big one, reducing the time the lights are on are very much going to reduce the amount of energy used. And so a few ways that we can do that. Photosensors will detect the daylight to reduce the electric lighting. Occupancy sensors detect when people are in the space. They can either turn the lights on when someone comes in, and then they have an automatic time for turning the lights automatically off as well. So there's a few types: passive infrared, ultrasonic, and dual tech. Demand response system, which will automatically dim the lighting down to a percentage, and you have to have a network system in order to do this. But you can dim all your lighting down if there's a peak energy event and you need to bring down energy quickly, or just to save energy. There's tailored solutions based on the type of occupancy and uses. So you may have some areas that you want to run on a time clock, if they're public spaces, and have them on during a certain time and then off during a certain time. There is dimming and scene settings, so dimming lights in specific areas and having certain scenes set for dimming different zones at different times. And then commissioning of the lighting system is a big one, having your commissioning agent come in after the fact, fine-tuning everything, finding ways that you can save even more energy based on how you use your building. So this is a really interesting study done by the IAS handbook, where we're able to reduce the illuminance without anyone noticing. So they did a study of the perceived light. They took a study of a group of people, and they dimmed lighting down and gave a survey on what was the percentage of light they perceived the dimming to be and what the percentage of light measured was actually. And they found during that study that dimming the light, you can see on this table here, 25%, the users actually perceive that as only being 50% dim. So we can dim a little more than we think we can in most cases. I know everyone has different, when it comes to lighting, very different views on what they like, but definitely you can dim a little bit more than you perceive you think you can. So now we're going to move on to a little bit about understanding the product life cycle and embodied carbon, to understand where our lighting fixture comes from, what goes into getting that fixture into your building, and sustainable ways that we can do that. So the overall, the embodied carbon, it really encompasses all these things: extracting the raw materials to make the product, transport to the factory, the manufacturing of the product, the transportation of it to the job site. So that also includes the packaging of the product as well. So a lot of lighting manufacturers I've seen are moving to more sustainable packing solutions, using recycled materials within their packaging, just to bring that footprint down a little bit. And then there's the building construction, so how the item is installed. There's the use and maintenance, which is the operating carbon usage. Building demolition, hauling the waste materials, recycling those materials, and then putting the ones that can't be recycled to landfill. So this encompasses the whole embodied carbon used for the cycle. And so now we're going to go a little bit about how life cycle analysis comes about. So the life cycle analysis kind of takes the recipe of all the ingredients in the product category, which is called the PCR. And so they evaluate the environmental impact. The life cycle assessment is an analysis to quantify the impacts of the full life cycle, kind of what we saw in the previous slide. And then they report all those findings and they put it into an environmental product declaration, which is called an EPD. There's a few others that you might hear about as a health product declaration, which is a HPD, and a product environmental footprint, which is a PEF. So all of these that are available, you can kind of see what goes into your product and the footprint of the product. So a little bit more about the life cycle analysis stage, and you may hear things such as cradle to grave and cradle to cradle, and what do those mean? So cradle to grave is when you start at the product stage for the raw material supply, and then you go to the end of life and the disposal and waste of that product. So that's cradle to grave. Cradle to cradle goes beyond that and goes to recycling and putting that into the next building. So starting all over again, cradle to start, basically. And cradle to gate is the raw materials to make the product, to get the product out the door to site. And so that's that product stage there. And we also have to think about the operational carbon, so the energy and water usage. And this is where our controls come in. So making sure that that fixture, how it's operated, you can really bring down the energy use with controls. So we really have an impact on what products are chosen and how they're used. And owners have an impact on how products are disposed or replaced after life. In order to get all these life, the LCAs and the EPDs and even Declare labels, there's a lot of work that the manufacturers have to do in order to get all this information. They need the weight of all the components, they need the materials used, the manufacturing processes used, all the lists of all their suppliers, packing and transportation methods. Sometimes they have to sign NDAs. And sometimes, there's always an LCA cost, which is about 20 to 40K, an EPD cost of 5,000 to 10,000K, and then a 5-year renewal. So we have to continually do this every 5 years. Break down, search all the materials, every little piece and part that goes into making their lighting fixture. So that's a lot of time and a lot of cost. But I think overall, we're seeing more and more lighting companies do this. They see the market as wanting to be really sustainable. And so the more we specify these products and the more we ask for them, the more this will become standard to have this reporting and this investigation done. And so that concludes our presentation for today. Hopefully you got some good insight into how lighting design is impacted by codes and standards, the impacts on the environment, how we can choose lighting to be not only sustainable, but also beneficial for our users and for the comfort of the people using the building. So this should be our main goal, and we should make sure we're always discussing and thinking about sustainability in our lighting designs. Thank you for joining us today. And I think we're going to go to any questions next. So let me know if there's any questions and put them in the chat, and so we can take a look. I'm not seeing any.
Yeah, Kristina, I'm not seeing any in the questions, but I have a question for you. As a mechanical engineer by trade, we do a lot of work with controls as well. And I'm curious what you've seen in terms of lighting controls and integrated building technologies, platforms where all means of control, whether it's HVAC or lighting, are integrated. Just curious if that's something that you're seeing more of in kind of these highly sustainable buildings.
Definitely. There's a new code requirement, I know in Title 24, and I think it's following up in other codes as well, where we have to have an automatic shutdown for mechanical in certain areas. So they have to use a lot of the time our motion sensors. And in order to do that, there's a few different ways, but the best way is to have a network lighting system with a kind of demand response main hub. And that way the BMS can tie into it easily. And so having those two interconnected, I think not only just for that code reason, but there's just monitoring, commissioning, everything is a lot easier if you can access all that information and they're all networked and connected together. So I think for someone that has and owns a building and maintains it, I think having that networking and having all that connection within the building is really going to save you a lot in the future for being able to monitor your energy usage.
Awesome, thank you. That answers my question. Well, if there are no other questions, we're happy to give people back a few minutes of their day before their next meeting starts. So I just want to thank everybody for participating in today's webinar. It wouldn't be an interface webinar without a pun. Roger Frechette, our managing principal, always tries to get a pun in, so I hope that you have found today's presentation illuminating. If you have any suggestions for improvements, please do send us a note and keep a lookout for the next interface educational webinar, KISS Systems, which is Keep It Simple and Sustainable. And that will be Jesse Augusta, principal with Interface Engineering, doing that presentation, along with Steve Gross and Michael Fleming, also principals across 3 different offices. So thank you, everyone, for joining, and enjoy the rest of your day.
Thank you.